Okay, so let's start with 25, okay, and see if we can work through these last few problems as quickly as possible. So the Hills purchased a home, okay, and notice I asked you to find the payments for each of them, okay. So let me read the problem on the review a bit. All right, so they don't know whether they want to do 20 years versus 30 years, right? So notice that they want to find the payment. Okay, you want to find the payment, okay? And then you have to figure out what you know, right? So we know present value, okay, just like the last problem. So we are going to use that amortization formula, which looks like this. So it's payment equals, okay, and then let's figure out what the rate is. So I'm going to kind of show you both of them, right? The interest is going to be 8% no matter what, divided by 12, okay? And the N is either going to be 20 times 12, so 240 payments, or, because we're trying to compare the two, 30 times 12, which is 360 payments. Okay, so the formula is going to look the same. We're just going to say, okay, we've got 0.08 over 12 times the 185,000 cash price of the house, and then over 1 minus 1 plus 0.08 over 12. Notice like the fractions are always the same on top and bottom, okay, no matter what formula you're using. And then you're going to say either to the negative 240 or to the negative 360 power. Okay, you'll have to figure these out separately, but my point is you're using the exact same formula. Okay, so this is a time where you might be able to use your second feature. Okay, so let's kind of talk about what I mean by that. So let's enter it in. Oh, first, before we do, let's put parentheses here and here. So let's do the 240 first. So 0.08 divided by 12 times 185,000. Divided by 1 minus 1 plus 0.08 divided by 12. So first I'm going to raise it to the negative 240 power, see what happens. Okay, so I get a payment of 1,547.41. Okay, so this is the 20-year payment. And then I want to compare that to the 30-year payment, so I'm going to do second enter because I want to do the same formula, I just want to change the 240 to 360. Okay, so notice it's a lot easier if you use that key. And so not surprisingly, it should make sense to you that this payment is smaller because they're having to pay it for a lot longer, right? So this would be the 30-year payment. Okay, so by the way, the reason someone might want to do this payment even though it's more is because you'll pay less in interest and you'll also be done paying for it a lot quicker than you will here. Okay, so that's why a lot of people actually pay their stuff off early because, you know, notice it's not a crazy amount more, right? It's just about $200 more, a little bit less actually, but you actually get to pay the loan off 10 years sooner. So it's actually kind of a big deal to pay a loan off quicker. So, all right, so number 26, she's saving for a trip that will cost her $8,000, right? So it's asking what payment, so it's asking you to find the payment. But this time, we don't know the present value, we know what she wants to have in the future, okay? So we know future value, which means it's the sinking fund formula, the other one, okay? So it will be that payment equals, so we'll do the interest rate off to the side again, so 0.05 compounded quarterly. So for N, we're going to have 4 times 4, right? 4 because it's quarterly, 4 because it's 4 years. And so this will be 16. So the payment will look like 0.05 over 4 times the future value she wants for her Hawaiian vacation, right, which is 8,000. And then on the bottom it is 1 plus the same fraction raised to the 16th power minus 1. Okay, insert our parentheses. So notice the reason we changed formulas in 26 compared with 24 and 25 is because this time we know the future value, not the present value. And so she would need to save $454.77. Okay. And again, if we wanted to know how much she had in interest, we would compare $454.77 times 16 payments and find out the difference between that and $8,000. Okay. 27. Michael's grandfather passed away, leaving him a trust fund of $100,000. Under the terms of the trust, he will receive the money in equal installments. Okay, that means equal payments. And so over the next 20 years, and it earns 7% compounded annually. What payment will he receive each year? So I'm asking you to find the payment. Okay, so here's where you have to think about, right? The $100,000 is not what he has in the future or what he has after interest. The $100,000 is what he presently has in cash from his grandpa, right? So this time we know present value, okay, not future value. Okay, so we use the other formula, the same one from number 24 and 25. Okay, so the interest would be 0.07 over 12. The N would be 1 time a year, right, times 20, so it's just actually 20 payments. So it's going to look like this. Fraction times how much his grandpa's inheritance is worth now, right, present value, and then over 1 minus 1 plus that same fraction, raised to the negative 20th power. Okay. Insert parentheses here and here. So you end up getting that he will get $9,439.29. Okay. So just to clarify, I know I didn't ask on this question, but just to clarify how much extra he's getting, let's figure it out. Okay, so he's getting $9,439.29 20 times. Okay, and so he's going to get a payout of $188,785, even though his grandpa only left him $100,000, right? And how come he's getting more? It's because this amount includes some interest, right? Like he's getting more than he would get if his grandpa just would have given him the money all up front. Okay, so that's why those companies like, you know, the J.G. Wentworths of the world are actually really ripping people off, because they're basically taking away the extra that they would get in interest, because the people are, you know, wanting to have their money now instead of waiting for the payouts. Okay, so kind of a little bit about some impatience there that cost them that much money. So, all right, number 28. Notice that I asked you to find out how long. So you're actually trying to find t. And also notice that the word continuously is used. So when we use continuously compounded interest, it's the PERT formula. Make sure you know that that's P times e to the RT power. Okay, let's read through the problem. So we start out with 5,000, and we want our money to triple, which means we want a final amount of 15,000. And then it's e to the rate is 7.5. What we don't know is t. So we've actually already done problems like this today, okay? In this review, we just didn't do it involving finance. So we need to solve for t, so we need to isolate that e part. So if we divide here, we get 3. And here we get e to that power. So if I want to get the t out of the exponent, and I do, I use the opposite of e, which is natural log. So I'm going to take the natural log of this side, but I have to do the same to this side. Okay, so what that allows for me to do is to move this around to the front because of the power rule. So we end up getting the natural log of 3 equals 0.075 t here. And then last but not least, if we want to know t, is just divide by that decimal. So we end up getting t equals 14.65 years if you plug that in. Again, make sure that you label the problem with what kind of unit it is. So if it's money, state that. If it's years, state that. If it's a percentage rate, then say that too. Okay, so just whatever it is, make sure you label it. All right, number 29. So she wants to retire with $1.2 million And the question is, in just how much should she save to do that, right? So we want to find the payment. So let's talk about what we know, right? We know not how much she has now, right? We know what she wants to have, which is the 1.2 million in the future, okay? So that means we need to use the payment formula that involves future fund, okay? Or future value, I mean. So payment equals, so we'll do the interest rate. So it is 0.06 over 12. The N is quite big, right? Notice she's 20 and she's going to save until she's 65. So that's 45 years, right? So 12 times a year for 45 years is quite a lot of savings deposits, right? Savings payments. So we are probably going to expect that, you know, she has a lot of time versus to save up her money, okay? So we've got 0.06 over 12. And then we've got 1.2 million. That's 5 zeros. On the bottom, we have 1 plus the same fraction to the 540th power minus 1. Okay, so just like we always do, we insert our own parentheses. And so she ends up that she needs to save about $435.41. Okay. If you're surprised by how small that is, just know that she's earning 6% interest and she's saving it for a long time, right, for 45 years. So actually a small amount of money equal to about a car payment can actually leave you with over $1 million at retirement if you kind of invest in the proper investments. So, okay, so last two questions. So the Bartletts are going to refinance their home. They have two options, blah, blah, blah. Okay, so for part A, notice that I said find the monthly payment, right? So I said to find the payment. So we only have two formulas that use payment, right? So the big thing is that we know not what we'll pay for the house in general, right? We know how much the house is currently valued at or priced at, okay? So when we know that, let's compare the two options. So we've got option A versus option B. So off to the side here, I'm going to do my interest. So the interest rate is different for both of them, right? It's 0.75 over 12 for the first one, right? This is option A. And for option B, it's different. So it's 0.725 over 12. Okay. Also, the N is different for both, right? The first one is a 30-year note, so it's 30 times 12 or 360. But this one is a 15-year note, so it's half the number of payments. It's only 180. All right, so let's get to it. So the payment is going to be that first fraction over 12, or number over 12, times the $150,000 that the house is being refinanced for, over 1 minus 1 plus the same fraction, raised to the negative 360th power. So parentheses, parentheses. Okay, so I'll tell you the answer that I get for that one, but let's set up the other one. Notice it's going to be the same format, but we got to change the interest rate. And we also have to change the number of payments. So make sure you're careful and make the appropriate changes, right? This should be to the negative 180th power. But again, we would simplify here. So we end up getting a payment of $1,048.82 here versus a payment of $1,369.29 here. Okay, not surprisingly, this one's cheaper, but that's because we're paying for double the amount of time. Okay, so it still would be much probably better to do this, right? Since that would charge us less in interest. Okay, but let's figure out if that's actually true. Okay, so for part B, I ask you to find the interest. Okay, and remember the interest is just the difference between the price, and what was paid. In other words, if they would have had $150,000 cash, they could have just paid for the house outright, right? But most people don't have that just sitting around. So we're going to compare the two. Okay. So again, we're going to compare option A versus option B. Okay, so remember, it's just the difference, right? So on the first one, we have payments of $1,048.82, but we have 360 of those, right? And then we're going to take off $150,000 because $150,000 is not the interest, right? It's what we actually paid for the house or what it's actually worth. So notice it is quite a large amount of interest. Okay, when you go to finance a house, you should be aware of this. Okay, the interest is actually more than what the house cost. Okay, and that's because it's over a 30-year period, right? So remember, when you're saving money, if you save it for a long time, you get a lot of interest, right? Well, when you're paying something off, if you take a long time to do that, you're paying someone else that amount of interest. So the second one is a payment of $1,369.29, but we're only making that 180 times minus 150,000. And so this comes out to be $96,472.20. So I mean, it's still a lot, but it's a lot less than here. Okay, so then the answer was, how much will you save by doing the cheaper plan, right? So you just need to find the difference between these two. So $227,575.20 is what you will pay in interest if you do 30 years. But if you sacrifice a little bit more every month, pay a little bit more, you will actually save $131,103 in interest. Okay, so this is your savings by paying it off early. By paying off in 15 years. Okay, so it's quite substantial. Okay. So notice at the beginning of all these finance questions, I wrote down some stuff, right? I always said, okay, this is what I want to know versus this is what I do know. And you should be able to figure out what formula to use from that, okay? So you'll want to make sure that you are familiar with the formula chart, but you don't have to necessarily know everything about it, okay? And so what I mean by that is, here's a formula chart. Now, I am going to give you one of these, okay? Now, I have a lot of things written on it. You can screenshot that or pause it if you want to kind of write that in on yours, but I think we're going to do that in class anyway. But notice, I'm going to give you this exact formula chart. So I'm not going to tell you what P and what A and what N and what M mean. You're going to have to know those things, right? But as long as you know those and you are familiar with these, then you should be able to pick out which formula to use. Notice, if you want payment, there's only two options, right? And it's either do you know present value or do you know future value? If you know the payment and you want to find either the ending amount, which would include interest, or the beginning amount, which would be before interest, then you pick between these two. Okay, so notice like they're actually in pairs, right? These two are in pairs. You pick between these if you want to know the payment. If you know the payment, you pick between these two, okay? These are if it's a lump sum investment. Okay, so maybe I'll write that. Actually, I did here. So this would be lump sum or one-time investments, and then this is the effective interest rate, okay? And then this is for simple interest. So they're actually literally in groups of two, the formulas are, okay? So you definitely need to be familiar with them, even though I'm telling you that I'm going to be providing them.